1.5 notes, inverses. We're going to show you what an inverse is graphically. Essential question. How do you graph and solve for inverses? What's an inverse? So an inverse, when we take an inverse of a function, we are essentially changing the x and the y location, right? So an xy ordered pair becomes y comma x. If we have a function f of x, its inverse is denoted as this. This is how we notate it. This means the inverse of f of x, the inverse of that function. Okay, so the negative 1 is not a power. It's not f to the negative first power. This is simply just the way of writing the inverse or notating the inverse. Example 1, so let's look at this quadratic function. This is the parent graph of a quadratic function. So we're going to plug in the points. So 0, 0. When x is 1, y is 1. When x is 2, 4. Negative 1, 1. Negative 2, 4. And let's go ahead and graph that. So let's zoom in a little bit here. So we have 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. And that's going to look like that. Now, take the table from y equals x squared, which we had on the previous slide, or it's right here, and reverse the order. So you can see that we are switching the x and the y coordinates. What was y now becomes x and vice versa. And this is called the inverse of f of x. So now let's take these points and let's graph them. So here's our inverse table. So let's go graph those points. See this one in red. So 4, negative 2 here. 1, negative 1. 0, 0. 1, 1. 4, 2. And we get a graph that looks like that. And this graph would be the inverse of f of x. Let's do a cubic function. So first let's graph the cubic parent graph. So 0, 0, 1, 1, 2, 8, negative 1, negative 1, negative 2, negative 8. And let's go ahead and plot those points. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 is going to be up here. We'll go off the graph a little bit. You guys don't have to because you're setting up your own graph. And it's going to look something like that. And that's the parent graph of a cubic function. So what we're going to do on the next slide is, once again, we're going to reverse the order of the ordered pairs. So negative 2, negative 8 becomes negative 8, negative 2. So negative 1, 0, 1, 2, and negative 1, 0, 1, and 8. And this is considered the inverse of that function. Let's go ahead and graph to see what that cubic looks like. So first, it says to graph all the points. So on this one, we're going to graph both the original one, which we had on the previous one, and also I'm going to graph the inverse so you can see. Let's do the original one in orange. So the cubic is going to look like this. And let's go ahead and graph that. That's our cubic function, right? So label that f of x. And we'll do the other one in blue. So we'll do the inverse in blue. So negative 8, negative 2. 1, 2, 3, 4, 5, 6, 7, 8. Negative 2 is probably like right here. Negative 1 is here. 0, 0, 1, 1. 1, 2, 3, 7, 8, 2 is going to be right here. So that graph's going to look something like that. Cool. So what do you notice about these graphs? Does anything come to mind? The question here does say, do they reflect somehow? And the answer is yes. We have this line right here, and I'm going to put that in black and line it up a little bit better. It's probably pretty good. This line is called, that's y equals x. And you can see that the original parent function, f of x, right? And then we have our inverse of f of x. The inverse of f of x is a reflection of f of x across the line y equals x. It's a reflection across that line. You may have noticed this parent graph. If you did, you would notice that this is what? Y equals cube root of x, right? And that is true because y equals the cube root of x is the inverse of y equals. So those are inverses of one another, okay? And they reflect across the line y equals x. So that's graphically what inverses look like. They will always reflect across this line y equals x. So you'll notice, let's go back to this one. So we should have graphed all points here, but if we look at the parent function, put that one in green from the quadratic that we were on, go back to it, we can see that, right, there's the parent function, and here's your line of y equals x, and we can see that, it's good, you can see that, it's a reflection across the line y equals x, so inverses will, graphically, will reflect across the line of y equals x. Okay, let's talk about algebraically. So here are the steps that you want to make sure that you have in your notes right here. How do you find an inverse algebraically? Those are the steps that you need to have, so pause and write those down. So the first thing we do here is f of x equals 4x minus 8. So it says to rewrite f of x as y. So we will do that, y equals 4x minus 8. It says to switch x and y, kind of like we do in the table, right? So that's what we're going to do, switch x and y. And then we're just going to solve this equation for y. So let's get y by itself. So we're going to have to add 8 to both sides. So I have x plus 8 equals 4y. And then we're going to divide by 4. We must divide all terms by 4. So we end up with y equals 1/4 x plus 2. 8 divided by 4 is 2. X divided by 4 is 1/4 x. So this is considered the inverse. And then at the end, we want to use proper notation. So we're going to switch y back to the inverse of f of x is equal to 1/4 x plus 2. And that's how you're finding an inverse algebraically. Let's try a couple more of these. Same exact steps. We're going to change g of x to y. So y equals square root of x minus 2. We're going to switch x and y. And then we're going to solve for y. So how do we solve for y? Well, to undo a square root, we're going to square that. If I square one side, I must square the other. So now I have x squared equals y minus 2. And we're going to add 2 to both sides. So my inverse is, so I'm going to write the inverse. Notice how I just changed y to the inverse is equal to x squared plus 2. This is the inverse of this original function. Let's look at one here. So we have h of x. I'm going to change it to y, and then I'm going to switch x and y. So I'm going to do that, those two steps kind of together right here. So I'm going to say this is x equals the cube root of y plus 3 minus 8. Now let's go ahead and solve for y. So we're going to add 8 to both sides. So we have x plus 8 equals the cube root of y plus 3. The opposite of a cube root is to cube. So we're going to cube that, and then we're going to cube this expression. So we end up with y plus 3. I'm just writing this first. Is equal to x plus 8 cubed. And we're just going to subtract 3 from both sides. So we end up with y, or now we're going to say the inverse, right, of f of x is equal to, and we shouldn't say f of x. We get used to writing f of x as a habit. It's actually h of x. So we should say the inverse of h of x. So the inverse of h of x is equal to x plus 8 cubed minus 3. And that would be considered the inverse of this original function h of x. Let's add one more example into your notes. So we have this function here, y equals 1/2 x squared plus 3. It's already switched to y, but I guess we can call this original function here f of x again. So we're going to change it to y and replace x and y, switch x and y. So I'm going to call it x equals 1/2 y squared plus 3. And now we're just going to solve for y. So we're going to subtract 3 from both sides. So we have x minus 3 equals 1/2 y squared. We need to eliminate this fractional coefficient, so we're going to multiply by 2 on both sides. So after we multiply by 2, sorry about that pause there. Let's go ahead and distribute this. So we have 2x minus 6 is equal to y squared. And then to undo the square, we must square root. That will cancel that. So we must have the square root of that. So we know that y, or y, is equal to the square root of 2x minus 6. And that's our inverse. So we want to give it proper notation. So we want to say the inverse of f of x is equal to the square root 2x minus 6. This would be considered the inverse of this original function, f of x. And that is solving for inverses algebraically. So those last few examples, those 4 examples we did, were solving for inverses algebraically as opposed to finding inverses graphically. Make sure you have a good summary. So I want you to really think about what you learned in this lesson and summarize that in a paragraph at the end of your notes.